Hello, everyone. My name is Katrina Rorhus, and I am studying archaeology at the University of Bergen. I also work as a scientific assistant for their Center for Early Sapiens Behavior. This is a center focusing on the Middle Stone Age site of Blombos Cave, South Africa, which is where that little arrow is pointing. I will be focusing today on the climate of Blombos Cave and how two approaches, namely qualitative and quantitative approaches, are relevant to Blombos Cave and to archaeology as a field. Blombos Cave is located on the tip of South Africa in a region known as the Greater Cape Floristic Region. This region today is characterized by its proximity to the coastline as well as a shrubby vegetation. However, that does not necessarily mean that this is what it looked like when Blombos was inhabited. This is a picture showing the wall of the cave. All of these white lines indicate separate layers where new generations of people lived. Since the cave was likely only used seasonally, it is possible to distinguish between each of these periods. Occupation began at the bottom around 101,000 years ago until 68,000 years ago at the top. After this, it was filled up with sand and was not used anymore. The site of Blombos has been preserved well despite its old age, so there's a lot of mammalian assemblage to analyze. A paleoecological reconstruction acknowledges that the landscape of an archaeological site found in the present may not be the same as it was when the site was in use. Erosion, climate change, glaciers, volcanoes, earthquakes, and other natural processes can radically alter a landscape even during the course of one generation. Given that the date of the first inhabitants of Blombos is around 100,000 BC, it is reasonable to suspect that the landscape has changed since then. To see what the climate of Blombos was like in the M3, there are two different approaches I will be using. The first is a qualitative approach. This kind of approach is not a formal technique, but if you read environmental archaeology papers, it comes up all the time in sentences like, because of the presence of this reindeer antler, there was likely a cold climate. These are statements based on a surface level analysis of animal remains. However, the problem with these statements is that they do not often take into account certain assumptions and biases that can be present, and I'll show you an example of this later on. The other more formalized approach is that of using quantitative or lab-based methods to analyze material. While this is an objective technique, which means it does not have any assumptions, it also involves altering or destroying material. This is a table I've adapted from Baden-Horst et al., which shows the number of bones found from each species on the left in each layer. The yellow boxes represent places where less than 10 bones of a species was found, and the green boxes represent places where more than 400 bones were found. By simply looking at this list, the rock hyrax, Cape Dune mole rat, and steenbok and griesbok were the most common animals. Does that mean that they were the most common animals in the environment? Not necessarily. They could have just been preferred diet of the prehistoric people living there. The assemblage also contains mostly smaller mammals, although this doesn't have anything to do with the climate either. Smaller mammals would have been much easier to catch than larger mammals, so it is likely due to this bias that there are more smaller mammals found at Blombos. Additionally, the number of animals seems to increase over time, although that might also not be explained by the climate. Studies of the artifacts at Blombos show that occupation of the cave increased over time, so it makes sense that food remains in the form of mammal bones would also increase over time. This chart shows all the species and their preferred modern-day habitats. This chart shows that the most commonly represented habitat was a scrub plain, savanna, and scrub forest. Unlike the four most common animals, this was a combined assemblage of all the animals, so it's much more likely to be indicative of the climate at the time. Therefore, it is actually very likely that Blombos had either a combination of these ecosystems or one of these ecosystems. In any case, it had a warm climate with sandy soils. In addition, we can see that the presence of seal bones indicates a proximity to the coast, and the hippo and reedbuck remains indicate wetlands. However, it is important to acknowledge that it is impossible to tell whether the bones were hunted locally or traded for by a tribe living in a different climate, or brought back by a long-distance hunting party. Before proving that, which can only be done by quantitative analysis, no qualitative conclusions can be made. For comparison, I will also be summarizing some of the key quantitative findings done by researchers at Blombos to show what kind of information they can reveal. The first study I looked at was a geochronological OSL study of the walls of Blombos Cave. OSL stands for optically stimulated bioluminescence and is basically a technique that allows geologists to see how long it's been since a sediment, like the rock on the walls of Blombos, were exposed to light. Since Blombos has been filled in with sand consistently throughout its occupation time, this is a great technique to show when certain layers were exposed and used. This study was the one that found the dates for the M3 layer. Although today Blombos Cave sits right on the Indian Ocean, a study by Jacobs et al. Found that there was sea levels had dropped so low during the M3 that there were 2.3 to 4.1 kilometers of seafloor exposed during this time. This was called the Palaeoecological plain and housed lots of herd animals that could be exploited by prehistoric peoples. The geology of a site is essential to understand in any quantitative climatic reconstruction. Geological analyses of Blombos found that the coastline is made of shale, a brittle rock that erodes easily with the rough waves of the coast. The erosion would have caused small intertidal bays all along the coast of South Africa and provided shellfish and other mollusks for people to eat. The cliffs surrounding Blombos are made of limestone, which created natural caves and rock shelters that are the hallmark of the GCFR. These shelters would have provided nests and dens for animals, as well as seasonal shelters for humans. So as we eat, we naturally absorb strontium, a kind of metal. Each of these strontium can have different kinds of isotopes, and the type of strontium that is absorbed is unique in every place. So by analyzing teeth and other bones, we can see where people have eaten and where the grasses came from. This study by Copeland et al. Shows that herd animals like the zebra actually prefer to live in the Palaeoecological plain next to Blombos, instead of in the mountains behind it, so it is likely that there was lots of herd animals available for them to eat. There are also a ton of other studies based on these. There have been studies on the snails found at the site, on the shellfish shells, isotope analysis of both carbon and oxygen, and paleosols. So there's still lots more information to be uncovered. I hope I have shown in this talk how qualitative analyses should be carefully analyzed before being used, and that all factors should be taken into account. While the qualitative analysis did not reveal much, it did show a good overview and gave some information. Qualitative analyses are also more accessible in terms of resources than quantitative methods. That analysis used only records of the mammalian assemblage detailed in other papers and was done by me, while a quantitative analysis requires highly trained professionals, access to a laboratory, and funding, in addition to having to destroy original material. The quantitative analyses give much more information. In summary, qualitative analyses are great for low-funded sites, quick overviews, or as a starting point, while quantitative analyses give more detailed and accurate information and are not subjected to biases and assumptions. And that's kind of all I wanted to say. So thank you very much.